Good afternoon, children. Today let me learn colloid, dispersion phase and dispersion medium. Origin of study of colloid starts with Thomas Graham, who observed diffusion of that a solution of sugar, urea or sodium chloride through a membrane, but not glue, gelatin or gum. Okay, so this origin of study of colloid starts with Thomas Graham. So he observed diffusion of the solution of sugar. Sugar solution diffusion means spreading the particles. So that the particles move through a membrane but not glue, gelatin or gum. So he called the former substances crystalloids. He first called the name crystalloids and the later as colloids. Okay, in Greek, colla as gum. Idios like gum-like substance. Colloids is a gum-like substance. Then later it was realized that any substance that be converted into colloid by reducing its particle size to 1 to 200 nanometer. The particle size is 1 to 200 nanometer means that particle is a colloidal substance. Hence, colloid is a homogeneous mixture of two substances in which one substance is dispersed in another substance. One substance is smaller proportion, another substance is larger proportion. Okay, dispersed phase and dispersed medium. Okay, dispersed phase or dispersion medium. In colloid, the substance present in larger amount, that is called dispersing medium. Medium means it present in larger amount. And the substance present in less amount is called dispersed phase. Okay, dispersing medium means like that solvent. Dispersed phase is a solute, lesser amount. Okay, so larger amount particle is dispersing medium. The substance less amount is called dispersed phase. Next, let me learn classification of colloids. So that two types of colloids, that is dispersed phase and dispersion medium. Okay, so the colloidal system have dispersed phase and dispersion medium. Dispersed phase is a solid, dispersion medium is a liquid. Okay, so dispersion medium is considered in water, then the colloid are referred as hydrosols or aquasols. So dispersion medium is water, so that colloids are called hydrosol. Hydro means water, sol means colloid, water colloid. Okay, so that hydrosol or aquasol. In dispersion medium is an alcohol, that colloid is termed as alcohol. Dispersion medium is benzene, that is called benzosol. Then one more type of classification based on force acting between the dispersal phase and dispersion medium. The colloidal solution can be classified into two types, lyophilic and lyophobic. Okay, first classification, dispersed phase and dispersion medium. So dispersed phase is solid, dispersion medium is liquid. Dispersion medium is considered as water, that is called hydrosol or aquasol. Dispersion medium is alcohol, that means alcohol. Okay, like that classification of colloidal solution, two types, lyophilic and lyophobic. That classification based on the forces acting between the dispersal phase and dispersion medium. First, let me learn lyophilic colloids. What is meant by lyophilic colloids? Colloids, another name sol, S-O-L, sol. Okay, so lyophilic colloids are sol, definite attractive force or affinity. That lyophilic sols have definite attractive force or affinity. It is exists between dispersion medium and dispersed phase. Okay, so here electron affinity or attractive force is between medium and dispersed phase. Dispersion medium and dispersed phase. Example, salts of protein and starch. Okay, protein and starch, their force of attraction is there. So that salts of protein and starch is more stable and will not get precipitated easily. That is starch, sugar solution does not get precipitated easily. Okay, so they can be brought back to colloidal solution even after the precipitation by addition of dispersion medium. Another type is a leophobic colloids. So just opposite to leophilic. Leophobic colloids, no attractive force between dispersed phase and dispersion medium. So, no attractive force. So these substances are less stable. Leophobic colloids are form precipitate. Okay, but cannot be produced again by just adding the dispersion medium. So leophobic are called irreversible salt. Example, salts of gold, salts of silver, salts of platinum, salts of copper. These are examples for leophobic colloids. So next, classification of colloids based on physical state of dispersed phase and dispersion medium. Everyone look at the tabular column. Very important 2-mark question. Okay, so here dispersion medium means larger amount. Dispersed phase means smaller amount. Okay, so here gas in liquid. Okay, so gas only more substance, liquid less substance. So that name of the colloid is liquid aerosol. Liquid aerosol. Example, fog. You know that fog, early morning. So aerosol spray. Okay, so aerosol spray also gas in liquid. Okay, so they will ask the question, give example for gas in liquid. That example is fog or aerosol spray. What is the name of the colloid? Gas in liquid. That is liquid aerosol. Second one is a dispersed medium gas. Dispersed phase solid. That name is called solid aerosol. So example, smoke. Smoke, gas plus solid. Air, gas plus solid. Pollutants like fumes, dust. So the next one, dispersion media, larger amount is liquid. Dispersed phase is gas. Foam. Okay, so that is wiped cream, shaving cream, soda water, froth. Next, dispersion media liquid. Dispersed phase also liquid. Liquid in liquid, that is called emulsion. Example, milk, cream. So that example of that emulsion is milk, cream, mayonnaise. The next one is a dispersion media liquid. Dispersion phase is a solid. That is salt. Name is called salt. Okay, ink, paint. Colloidal gold. These are the examples. Next, solid in gas. That name is called solid foam. So that example, fumic stone, foam, rubber bread. The next one, solid in liquid, gel, butter, cheese. Solid in solid, solid salt, pearls, opals, colored glass, alloys, colloidal, dispersed, utilics. Okay, solid in solid, solid salt. Examples, pearls, opals, colored glass, alloys, colloidal, dispersed cuticles. Okay, So next one, preparation of colloids. Next let we learn preparation of colloids. Very important, 3 more questions are there. Okay, so many lyophilic substances are made their colloidal form by warming with the water. Lyophilic substance, how to prepare the lyophilic substance? That substance warm with water. Rougher forms colloidal solution with benzene. So spontaneously forms a colloidal solution by just mixing with the water. These are the example for lyophilic. In generally, colloidal solutions are prepared by 2 methods. What are the 2 methods of preparation of colloids? Dispersion method and condensation method. What are the 2 methods of preparation of colloids? Dispersion method, condensation method. So dispersion method means, in this method larger particles are broken to colloidal dimension. Okay, larger particles broken down into smaller particles, that is colloidal dimension means that minute particles. Okay, so next one is a condensation method, just opposite. In this method smaller atom or molecule are converted into larger colloidal size particles. Okay, so preparation of colloids, 2 methods. First let we learn dispersion method. Totally 4 dispersion methods are there. First one is a mechanical dispersion method. Okay, so in mechanical dispersion method we are using the colloidal mill. This is the structure of colloidal mill. Okay, so that colloidal mill containing 2 metal plates. The colloidal mill containing 2 metal plates. Okay, so these 2 metal plates rotate in opposite direction at a very high speed, that is 7000 revolution per minute. Per minute how many revolution? 7000 revolution. Okay, so very high speed. Okay, so using a colloidal mill, the solid is ground to colloidal dimension. Okay, the solid is ground to colloidal dimension. That means very big, that substance broken to colloidal size. Okay, colloidal size means 1 to 200 nanometer. Okay, the colloidal mill consists of 2 metal plates rotating in opposite direction at a very high speed of nearly 7000 revolution per minute. The colloidal particles of required colloidal size is obtained by adjusting the distance between 2 plates. Okay, according to the size of the colloidal particle, first we want to adjust the 2 plates. Okay, by this method colloidal solution of ink and graphite are prepared. In that mechanical dispersion method we will prepare the colloidal solution ink and graphite. Okay, then second dispersion method is a electrodispersion. A brown colloidal solution of platinum was first prepared by George Frederick in 1898. Okay, in brown colloidal solution of platinum, brown color colloid solution of platinum, okay, was first prepared by George Frederick in 1898. An electric arc is struck between electrodes. Electric arc is, so here this is a arc. Okay, that yellow in color, that electric arc is struck between electrodes, positive and negative electrode. In between electric arc is there. Okay, an electrical arc is struck between electrodes disposed in water. Okay, so this electric arc is disposed in water. Arc is in the place of water. Okay, so that water surrounded by ice is there. Water surrounded in this place full of ice, in this place full of water. Okay, so in the water electric arc is there. That electric arc stuck between two electrodes. Okay, so an electrical arc is stuck between two electrodes. That electrodes dispersed in water surrounded by ice. When current of 1 ampere per 100 volt is passed in an arc. Okay, so here we want to pass the electric current 1 ampere per 100 volt is passed an arc produced forms vapors of metal which immediately condense to form colloidal solution. So at that time that electrical arc it produced forms vapor of metal. Okay, that electric arc converted into vapors of metal. So outside full of ice is there. So immediately condensed to form a colloidal solution. By this method, colloidal solution of many metals like copper, silver, gold, platinum, etc. can be prepared. Alkali hydroxide is added to a stabilizing agent for the colloidal solution. In this colloidal solution, we are using the alkali hydroxide. Any one alkali hydroxide is used as a stabilizing agent for stable purpose. Okay. So the next, Swedenborg modified this method for the preparation of non-aqueous inflammable liquids like pentane, ether and benzene etc. using high frequency alternating current which prevent the decomposition of liquid. Okay, Swedenborg modified this method, preparation of non-aqueous inflammable liquid. That inflammable liquids are pentane, ether and benzene. These and all using in high frequency alternating current which prevent the decomposition of liquid. Okay. Next, third, ultrasonic dispersion. Third method is ultrasonic dispersion. Okay, ultrasonic sound waves of frequency more than 20 kilohertz, that is ultrasonic. Okay, sound waves of frequency more than 20 kilohertz. So that is audible limit only, 20 kilohertz could cause transformation or cause suspension of colloidal dimension. Okay, so that glass obtained mercury salt by subjecting mercury to sufficiently high frequency of ultrasonic vibration. Here we are using the substance is mercury. See the diagram. In the beaker bottom that mercury is there. The next water. That mercury cannot dissolve in water. It is a immiscible substance. We can see the separate layer. Okay, so that vessel surrounded by oil. Okay, so here they are connecting the quartz generator connected with the electrical oscillator. So ultrasonic vibration produced by generator spread the oil and transfer of vibration to the vessel with mercury in water. Here we will pass the electric current. Ultrasonic vibration produce the generator. Okay, generator is in the oil. Okay, so that oil transfer the vibration to the vessel of the mercury in water. That is ultrasonic dispersion. Okay, in this ultrasonic dispersion, the ultrasonic vibration produced by the generator vibration spread to the oil. That oil transfer the vibration to the vessel of mercury in water. That mercury is split into colloidal particles. Let me learn. Next condensation dispersion method is peptidization. Okay, by addition of suitable electrolyte, precipitated particle can brought into colloidal state. Precipitated particle means deposited down. That particle change brought into colloidal state. This process is called peptidization. Here we are using the electrolyte, that is called peptidizing or dispersing agent. That electrolyte is dispersing agent. Example, silver chloride, AgCl. So the AgCl is a precipitate. By adding electrolyte hydrochloric acid, okay, hydrochloric acid a peptidizing agent, so that AgCl precipitate is converted into AgCl colloid. Okay, have you understood preparation of colloids? The first method is the dispersion method. Larger particle converted into colloidal particle. Colloidal particle size is 1 to 200 nanometer. Okay, so that dispersion method. First method is a mechanical dispersion. So mechanical dispersion, manually rotate the plate at a very high speed. Okay. So second one is a electro dispersion using the electric current. So third one, ultrasonic dispersion. Okay, sound waves at high frequency 20 kHz. Third one is a peptidization. Precipitate is converted into colloidal particle. So then second type of preparation is condensation method. When a substance for colloidal particle is present, small sized particle. Condensation method, small sized particle or molecule or ion, they are brought to the colloidal dimension by condensation method. So here, to produce the particle with the colloidal size, otherwise precipitation will occur. Various chemical methods for the formation of colloidal particles. So condensation method containing various chemical properties. The first one is oxidation. Salts of some non-metals are prepared by this method. Oxidation method. Non-metals are prepared by oxidation method. So the first one is when hydroiodic acid, HiO3, hydroiodic acid is treated with iodic acid, iodine salt is obtained. Okay, hydroiodic acid is treated with iodic acid to form iodine salt. HiO3 plus Hi gives H2O plus I2. I2 is a salt. When oxygen is passed through H2Se, selenium hydride, a salt of selenium is obtained. H2Se plus O2 gives Se salt, selenium salt. How to prepare iodine salt and selenium salt? First one, iodine salt. How to prepare? Hydroiodic acid is treated with iodic acid. Iodine salt is obtained. Oxygen is passed through selenium hydride. Selenium salt is obtained. Okay. Then second preparation is a reduction. Most organic reagents like phenyl hydrazine, formaldehyde, etc. are used for the formation of salts. Okay, organic reagents like phenyl hydrazine, formaldehyde that are used for formation of salt, colloidal substance. Example, gold salt is prepared by reduction of Re chloride using formaldehyde. Okay, so Re chloride AuCl3. Re chloride reduced by formaldehyde HCHO in presence of water to form gold salt. Au plus HCl plus HCOOH formic acid. So third one is a hydrolysis, addition of water. Salts of hydroxides of metals like chromium and aluminum can be produced by this method. Okay, chromium, aluminum, these metals are produced by iron. Okay, so example, FeCl3 ferric chloride is hydrolyzed, addition of water to form ferric hydroxide salt plus HCl. Okay, so then fourth one is a double decomposition. For the preparation of water insoluble salt, this method can be used. Okay, double decomposition method we can use to prepare water insoluble salt. Okay, that salt cannot dissolve in water. When hydrogen sulfide gas is passed through a solution of arsenic oxide, yellow colored arsenic sulfide is obtained as colloidal solution. Okay, so here arsenic oxide passed through the gas hydrogen sulfide to form the salt is arsenic sulfide. As2O3 plus H2S gives As2S3 plus water. Next chemical properties is a decomposition. Okay, when few drops of acid is added to a dilute solution of sodium thiosulfate, Na2S2, sodium thiosulfate means Na2S2O3, that Na removed, so S2O3 minus this compound. Okay, so when a few drops of an acid is added to dilute solution of sodium thiosulfate by adding acid, for example HCl or H2SO4 or HNO3. So insoluble free sulfur is produced by decomposition of sodium thiosulfate accumulate into small cluster which impart various colors, blue, yellow and even red to the system depending on the growth within the size of colloidal suspension. Okay, so the sodium sulfate treated with any acid, it will form sulfur salt. That sulfur salt maybe it will blue color, yellow or even red also. Then condensation, first method is a chemical properties. So 5 properties we studied. First one oxidation, second one reduction, third one hydrolysis, fourth one double decomposition, fifth one decomposition method. Then third type is a exchange of solvent, by exchange of solvent. Colloidal solution of few substances like phosphorus or sulfur is obtained by preparing the solution in alcohol and pouring them into water. Okay, so that few substances like phosphorus, sulfur, how to prepare that phosphorus salt and sulfur salt? So first that phosphorus in alcohol is treated with water to form phosphorus salt. Phosphorus in alcohol plus water gives phosphorus salt by exchange of solvent. Next method purification of. So next let me learn purification of colloids. How to purify the colloidal substance. The colloidal solution due to the different methods of preparation may contain impurities. So that colloidal prepared by different methods, it contain impurities. They are not removed, they may be destabilize and precipitate the colloidal solution. This is called coagulation. So what is meant by coagulation? Colloidal solution is prepared by different methods. That colloidal solution may contain impurities. They are not removed, they may destabilize and precipitate the colloidal solution. That is called coagulation. Hence the impurities, mainly electrolytes, should be removed to increase the stabilization of colloid. So purification of colloidal solution can be done by 3 methods. So the one is dialysis, another one electrodialysis, third one ultrafiltration. 3 methods used to purify the colloidal solution. First let me learn dialysis. In 1861, T. Graham separated the electrolyte from a colloid using semi-permeable membrane. That is called dialyzer. Okay, semi-permeable membrane. Okay, in 1861, T. Graham separated the electrolyte from the colloidal substance using semi-permeable membrane. That is, semi-permeable membrane is called dialyzer. Okay. In this method, the colloidal solution is taken in a bag. That bag is made up of semi-permeable membrane. It is suspended in trough of flowing water. Okay. The electrolyte diffuse out of the membrane. Electrolyte means positive and negative ions diffuse out of the semi-permeable membrane. They are carried out away by water. Okay, this electrolyte is carried out away by water. Second method is a purification method is electrodialysis. The presence of electric field increase the speed of removal of electrolyte from colloidal solution. Okay, electric field increase, the electrolyte from colloidal solution removal also increased. The colloidal solution containing an electrolyte as impurity is placed between two dialysing membrane. Okay. So enclosed into two compartments filled with water. So two compartments filled with water. When current is passed, the impurities pass into water compartment and get removed periodically. That impurities passed into water compartment. Two compartment is there. That impurities, that means electrolyte passed into water compartment. So and get removed periodically. This process faster than dialysis, as the rate of diffusion of electrolyte is increased by the application of electricity. Then third method of purification is ultrafiltration. The force of ordinary filter paper permit the passage of colloidal solution. Ordinary filter paper, we know that filter paper pass the colloidal solution. So in this filtration method, we will use the membrane are made by using colloidal cellophane or whisking. Okay, so that means very minute pores are there. When a colloidal solution is filtered using such filter, colloidal particles are separated on the filter and the impurities are removed and washing. Okay, colloidal particles are separated on the filter, the impurities removed as washing. This process quickened by the application of pressure. We want to apply the pressure. The separation of salt particle from electrolyte by filtration through an ultrafilter is called ultrafiltration. What is meant by ultrafiltration? The separation of salt particle from electrolyte by filtration through an ultrafilter, that is called ultrafiltration. Colloidin is 4% solution of nitrocellulose in a mixture of alcohol in water. Colloidin, that is filter. Okay, that is 4% of nitrocellulose in a mixture of alcohol and water. It is made up of 4% of solution of nitrocellulose in a mixture of alcohol and water. Let me learn properties of colloids. So the first properties of colloids is color. The color of a sol is not always the same as the color of the substance in the bulk. Okay, the color of the sol is not always same as the color of the substance in the bulk. For example, bluish tinge is given by diluted milk. In reflected light, and reddish tinge is transmitted light. Okay, so here we are using bluish tinge is given by diluted milk. Okay, but that reflection light, we will see that color is reddish tinge, that it is transmitted color. Okay, color of the sol generally depends on the following factors. One is method of preparation. Second one, wavelength of source of light. Third one, size and shape of colloidal particle. Fourth one, whether or the absorber views the reflected light or transmitted light. Okay. So second property is size. The size of colloidal particles range from 1 mu okay to 1 m diameter. The size is that micro, very small size. Okay, so 1 micro mu to 1 mu micro diameter. So third point is a colloidal solution are heterogeneous in nature, having two distinct phase. Okay, heterogeneous means different phase. Okay, through experiment like dialysis, ultrafiltration and ultracentrifuging clearly show the heterogeneous nature. In the recent times, colloidal solution are considered as borderline cases. Okay, here we are using the heterogeneous in nature, that means solid and liquid. So they have in distinct phases, different phases. So then fourth property is filtrability. As the size of pores in ordinary filter paper are large, the colloidal particle easily pass through the ordinary filter paper. So fifth point, non-setting nature. Colloidal solution are quite stable, that is they are not affected by gravity. Then sixth point, concentration and density. When the colloidal solution is dilute, it is stable. Colloidal solution is dilute, that colloidal solution is stable. When the volume medium is decreased, coagulation occurs. That volume is decreased, coagulation occurs. Generally, density of salt decrease with the decrease in the concentration. Then seventh point is a diffusibility. Unlike true solution, colloids diffuse less readily through membrane. Okay, so colligative properties. The colloidal solution show colligative properties. That colligative properties means elevation of boiling point, diffraction in freezing point, osmotic pressure. So measurement of osmotic pressure is used to find molecular weight of colloidal particle. Using the osmotic pressure, we can find the molecular weight of colloidal particle. Shape of colloidal particle. It is very interesting to know various shapes of colloidal particle. Here are some examples. Size of shape of colloidal particles. As2S3 arsenic sulfide, so that shape is spherical in shape. FeOH trice salt, that is ferric hydroxide blue gold salt, that shape is disc or plate like shape. W3O5 salt, that is tungstic acid salt, that is rod like in shape. So next one, optical activity.